Hello everyone, welcome back to another exciting chemistry video lessons from Adrenaline, the Bazooka Prophet. And today we are going to be talking about configuration of compounds with more than one stereogenic center or more than one chiral centers. Now on the board we are having two compounds here, right? And each of these compounds both possess two chiral carbon. So we have to determine the R and S configuration. If you are just watching this video for the first time, please do well to check my previous post on my videos on stereogenic centers. That is just one. This one is not more than one, so I'm going to be doing it together. Now listen. A lot of students have had many issues on things like this, but they do not understand the foundation of how it works or how it operates. So in this video, I'll be telling you how to do it with what now? With ease. Is that clear? Now let's go. So this is a chiral carbon. Yeah, we need to determine whether it is R and X. So how do I go? Remember in our previous post, I said that it is determined based on atomic number. So I come here. Here has, because here have atomic number of what now? 8. So here we take the higher priority. So I am considering only the oxygen, not hydrogen. It's only when along the line I'm not seeing any difference. That's when I move to the next one. Look at it. So here is 1, right? Now, here is 1. This carbon here is directly attached to everything here. And everything here, right, is higher than this carbon here. Meaning this carbon here and this carbon here, no difference. So I can now move to the next until you spot a difference between this particular group here and this particular group here. So automatically, this one is higher. This one is of higher priority compared to what now? Compared to this carbon here, right? So here becomes what now? 2. Here becomes what now? 3. Right here the list here. So if you look at the way it is going now, it is going in this direction, which is arrow direction. Is that clear? Now, if I am done with this one, now look at it. I'm considering it carbon, chiral carbon by chiral carbon. I have been able to identify this chiral carbon. The next is to move to the next chiral carbon. And in doing so, I will need to what now? Erase this, right? To make it stay neutral here. This is a rough work. So this is arrow. Now I now move to this other chiral carbon here. Now in this chiral carbon here, what are the groups attached to it here? I'm having chlorine, I'm having this carbon, I'm having this other group of carbon, and other subject 20 and hydrogen here. So automatically, based on the first bond directly attached to the atom, this one has the higher atomic number here. So chlorine will take 1. Of course, between this methyl group and this other carbon group here that have other group attached to it, this one should have a higher priority here, right? So here is 1, here is 2, followed by what now? 3. The list here is what now? 4. So if you look at the way it is going, right? It is going what now? In the what now? Arrow direction, which is clockwise direction. But remember I told you in my previous video that the least atom is always placed in the dash. Is that clear? Because this wedge is what is pointing towards you, while the dash is what is at the back. It's at the back, right? So because this hydrogen atom was not placed in its correct bond, we will now have to interchange it. So for it to be arrow, we'll swap it. It becomes what now? X, right? If it was X before, it will now turn to arrow. So now I've been able to define here like this. So here is arrow, here is what now? X. Take note. So I can now name it nomenclature form. So permit me, let me erase the board here. Now I now know that here is X. So I can now name it. I can now name it in its appropriate place. So let's name together. Now, of course, in naming this organic compound here, the highest, the functional group here is what now? Hydroxyl group. So I'll start my numbering from here. Here is 1, here is 2, here is what now? 3. Longest carbon chain while you are naming your organic compound. So already now, because I'm starting from here, and already here was arrow, Abi. So here was 1. Oh, sorry, the number of carbon here is 4. Please permit me. Here is 1, here is 2, here is 3, and here is what now? 4. So here become 1, 2, 3, 4. So that the substituent here is just a methyl group. So I come here to now say here becomes what now? 2 carbon 2 here has the arrow here because this is the chiral carbon here. 2 arrow, comma 3 X. Then what do I do next now? Here becomes what now? 3 methyl, sorry, 3 chloro, right? 3 chloro butan 2O. And this is how easy the naming of this compound is. So if I've been able to do this for you, you do well now to do this for me and tell me your answer below, right? If this video has helped you, do well to like, subscribe, and share. Remain blessed, and God bless you.